Okay. We're going over SOH CAH TOA, which are primary trig ratios. We'll quickly talk about them here. Our very first one we're going to be looking at is sine and theta. Theta stands for an unknown angle. Okay? And the reason they call it so is sine theta is equal to opposite divided by the hypotenuse. Okay? So for so, that would be sine opposite over hypotenuse. This acronym here helps us remember our ratios. The second one we need to remember is cosine theta is equal to the adjacent side of the triangle divided by the hypotenuse, which is our cosine adjacent hypotenuse. And finally, TOA, which is tangent over opposite, tangent is equal to opposite over adjacent, so tangent, opposite, adjacent. Now, when we're using these primary trig ratios, we can only use them with specific triangles. What types of triangles can we use them for? They have to be right angle triangles or have an angle that's 90 degrees in them. Now, the hypotenuse will always be the same side of the triangle. It will always be opposite of the 90 degrees, which will make it the longest side of that triangle. Okay, that's why we have it in purple here. But the opposite and adjacent change depending on what angle of the triangle we're referring to. So in our first example, where the angle is here, the opposite side is the side of the triangle that is not touching that angle. Okay, hence why we have it in blue. Where the adjacent side, adjacent means to be touching, and technically there are two sides touching this angle, but one of them has already been named the hypotenuse. That is always a for sure. So that means the other side touching it must be the adjacent. Okay, and same with this angle here. Now when we refer, let's assume these triangles are identical. I know they're not drawn perfectly, but if we're talking about this angle, this then becomes the opposite side of the triangle, and the adjacent side is this side here. Okay, so opposite and adjacent is interchangeable, but hypotenuse is a definite side. We have a triangle here, and what we're going to do is try to use our primary trig ratios to solve this triangle. So we're going to solve all parts of this triangle. Many of you will probably be able to do it without that stuff, but we're going to do it using our primary trig ratios. So first off, according to this angle, what side of the triangle do I have a measurement of? That's right, we do have the opposite side. It's 8. So we're going to try to plug it into all three of the ratios. We have sine, theta, and theta in this case is 45. Okay, so we'll normally replace that with 45. Is equal to opposite, well, we have the opposite side. It's 8 over the hypotenuse. Okay, cosine theta, theta being 45, is equal to adjacent, which we don't have, over hypotenuse. And finally, tangent theta, which is 45 again, is equal to opposite, which is 8 over adjacent. I'll write those in after, 45 and 8. So, if you look, for two of the ratios, we have 2 out of 3 of the variables. In other words, there's only one unknown with our sine ratio and with our tangent ratio. Our cosine ratio, we have at least 2 variables here with only one known, which means we don't have enough information to find anything else about this cosine ratio. Because they want us to solve every part of the triangle, I can choose either of these to work with. Using sine, I can find the hypotenuse, and using tangent, we can find the adjacent side. Okay? So we'll start with sine here. We have sine 45 is equal to 8 divided by h. Okay? Well, we need to bring that h to the other side. Okay? Our whole goal is to isolate h, get it by itself. Think of this like we're cross-multiplying. That would be the fastest way to get this out of fraction form. Because they're equivalent ratios, we cross-multiply, and we'll be left with h times sine 45 is equal to 8 times 1, which is just going to be 8. Okay. Now, what is the goal again? What are we trying to get by itself? H. We're trying to get h by itself. So we have h times sine 45 is equal to 8. You could put sine 45 into your calculator and get a decimal, but we can move it as a function right now. How do I get h by itself? What do I need to move? All right, we need to move this sine 45, and when it goes on the other side, it's not negative. Divided, because here this means multiplication. So in order to move it, we need to divide by sine 45 on the other side. Okay, technically we're doing that on both sides. So we're then left with h, that is equal to 8 divided by sine 45. Okay, so our hypotenuse is equal to, we'll take out our calculator here, 8 divided by, and I'm going to have to put in brackets, 45 sine, it gives me a value. Okay, so sine 45 is 0.7, and make sure your calculator is in degrees, not radians, okay? So altogether equals 11.31. So our hypotenuse in this case is 11.31. So we go back up to the top, we got this, 11.31, whatever the unit of measurement is. We can also use tangent, since we set up at the beginning, to find the adjacent side. So using roughly the same idea, not sine, tangent 45 is equal to opposite, which is 8 over adjacent. Now, I want you guys to notice a pattern here. Instead of doing all of these steps in here, what did I quickly do? From here all the way down to here. How can I do this? What can I switch in one quick step? That's right. We switched h and sine 45, right? The h was down here, the sine 45 was here. I showed you algebraically what you're technically supposed to do. And if you do that properly and know that it's the proper rule, we can just switch the h with the sine 45 and the sine 45 with the h. So my next thing read, what would this read if I want it to be equal to a? It'll say a is equal to what? That's right. There's a little shortcut we can use. So we've just rearranged that very quickly, so we can now solve it in almost one step. Take out our calculator again. Same idea. 8 divided by, we'll put our brackets, 40, oh, I don't think that worked. 8 divided by bracket, there you go, 45 tangent, where's tan? There it is equal to 8. Okay. So in other words, the other side of this triangle, or the adjacent side here, is a measurement of 8. Okay, that does make some sense. Now that I have the hypotenuse at 11.31 and the adjacent side at 8, we're going to put into cos to solve for our other unknown angle. I'll call it the blue angle in this case. Okay? So now that this is the blue angle, cos deals with adjacent and hypotenuse. What is the adjacent side to this angle? Which 8? The bottom 8. This then becomes the adjacent side. Had these been different numbers, okay, we had to keep that in mind. This bottom 8 is now the adjacent side. Now, I know it looks like it wouldn't have made a difference if we used this side here, but had this been 6, okay, it would have been very important that we made sure that we knew to switch, that this then became the adjacent side, and this is the hypotenuse. So, we take our cos of our blue theta, that's our unknown, is equal to adjacent, which happened to be 8, over 11.31, I think I said. Okay. Now here, the goal is to get theta by itself. In other words, I need to bring cos to the other side of the equation. Now, cos stands for an in-depth equation which we put some value into. To move it, it looks like it's multiplied, so we would maybe divide by cos on the bottom of the fraction, but if you do that on your calculator, divide by just cos, you'll get an error. What you actually need to punch in is cos inverse, okay? And when we get into exponents, we'll talk about why we use the inverse of cos. But we need to put, when we move cos to the other side of the equation, it needs to become cos inverse. So on a lot of your calculators, you might have to hit second function of 8 divided by 11.3. Now you can do the 8 divided by 11.3 and get a decimal first and then do cos, or you can do it all in one shot. So I'm going to do it all in one shot. 8 divided by 11.31, and then I'm going to do cos inverse. So inverse, and you see how I get cos to the power of -1 there? I hit that button. 44.98, and that's because I rounded my 11. It should really be, what can I round that to? 45, okay? And it shouldn't be approximate. It is 45. Okay, so our other angle down here is 45. Does that make sense? Both these angles being 45? Yeah, it's an isosceles triangle, right? Both of the sides were the same length, so it makes sense that these angles are identical. Now, we went through the processes of essentially using all of the primary trig ratios. Early on, though, I could have found this angle much easier. Once I had this angle and the right angle, what would have been the fastest way to find this angle? Not Pythagorean theorem. Add them to what?
90 plus 45.
Yeah, what's the whole triangle add up to?
180.
180, that's right. So we could have added 90 and 45 and subtracted that from 180. It would have gave us 45. And PJ, what did you say before when we had this side and one other side of the triangle? How can we find this side? Pythagorean theorem, right? We didn't technically have to go back into a primary trig ratio. We could have used that stuff. All right, there's one last thing you need to know. We'll talk about very briefly. Angles of depression and elevation. Okay? From a horizontal line. Depression and elevation have to be measured from a horizontal line. You have an angle going up, and you have an angle coming down. Okay? The angle going up is known as what? Anyone know? Angle of... You have two options, elevation or depression. Elevation. Makes sense. It's going up, right? Elevation. Which by default means the angle going down from a horizontal is what? Angle of depression. You need to know those as definitions for some of the work you're going to be doing. Okay, so that's everything we've done today. That's all you need to know.